Hi, Shane Seegers, and today I'm going to be performing a chemical reaction video for you. What we're going to do is we're going to dehydrate sugar. And what I mean by that is we're going to take all the water out of the sugar and turn it basically into elemental carbon, as well as some water vapor, sulfur dioxide, and carbon dioxide gas. When something like sulfuric acid is added to sugar, the hydrogen ions in the sulfuric acid are immediately attracted to those hydrogen, oxygen, and carbon bonds in the sugar. As they're attracted to it, they sort of break apart the carbon's hold on the hydrogen and oxygen. So what you're left with is the pure carbon, as well as some water vapor, carbon dioxide, and sulfur dioxide gas. So when talking about bonding, what's really important to note are all these elements, they all have electrons surrounding the protons and neutrons in the nucleus. When something like hydrogen, for example, is just one proton and one electron, there are no neutrons. So with a acid, what we're really talking about is just a proton, because the hydrogen no longer has its electron with it. So it's positively charged and is in search of other electrons. So when these hydrogen ions are introduced to a substance, they're really trying to just look for electrons they can attach themselves to. So the hydrogen is kind of ripping apart the electrons as it takes those electrons, the oxygen is no longer bonded to the carbon, and instead it frees the carbon so the hydrogen and oxygen bond together to form water. Before doing any chemical reaction, you first want to make sure you're practicing the proper safety protocols. So you'll see that I'm wearing gloves today. I'm also going to be wearing goggles as well. Perfect. I'm also wearing a long sleeve shirt. Since we are working with sulfuric acid, it is very corrosive. You definitely do not want to get this on you anywhere. So you want to make sure you wear it safe. I also want to wear a face mask as well. Since we are working with an acid with a tendency possibly to splatter a bit, you want to make sure you have as much skin covered as possible. So once the reaction starts, I will put on a face mask as well. So since we're going to be using sugar, one thing to remember here is exactly what is sugar's chemical formula. We are going to be using table sugar, which is sucrose. Sucrose has the formula C12H22O11. So it's actually a disaccharide. It's composed of both glucose and fructose joined together. When you have those two sugars joined together, you end up with table sugar. So as I was saying, sucrose is C12H22O11. If you're looking at that formula, when you have H22 and O11, think about possibly a common denominator there. So you can actually, by pouring sulfuric acid in there, take out the H22O11, which really, boiled down, is water, H2O. So what we're left with is just pure carbon. So during the reaction, the sulfur will also bond with oxygen to create sulfur dioxide gas, which in higher quantities is pretty toxic. So we want to do this outdoors. I have seen videos where people have been doing this indoors and in non-ventilated areas. That's probably not the best idea. When I took chemistry in college, we actually did this in the chemistry lab, and there were no windows open at the time. So doing it in a chemistry lab probably wasn't the safest thing to do because we did not have a fume hood available to suck up the fumes. But we are outdoors here, we're at the top of a building, so any fumes should escape easily. So the first thing I need to do is make sure I've got my sugar settled inside the beaker. Next, I'm going to take some sulfuric acid. As you can see, it is packaged pretty well. It's inside a cardboard box, inside a plastic Ziploc bag, and wrapped in paper. Now, paper is probably not the best place to put it because it does break down any sort of organic material. There is carbon in this paper, so if it goes to fall on the paper, it would actually char the paper. So we have some fairly highly concentrated sulfuric acid, anywhere from 95 to 98% sulfuric acid. Once we add this to the sugar, you're going to see what was originally a clear yellowish liquid begin to turn brown. What's happening is that the sulfuric acid is taking the water out of the sugar. Now you're looking at the sugar and thinking, well, that's pretty dry, where's the water? Well, the water's inside the molecule itself. Once again, C12H22O11. If you isolate that H22 and O11, bring it down, that's H2O. There's water inside the sugar. So since this is a highly caustic substance here, first thing I want to make sure I have my stir rod available. I'm also going to make sure the cap is off. And we have to be very careful. This is a highly exothermic reaction as well. It gets hotter than 212 degrees Fahrenheit, which means that any water in there is going to boil. You're going to see steam coming up out of this. Since I am about to begin this reaction, I'm going to make sure I put on the face mask as well. So remembering that we are dealing with a very caustic substance that loves to attack mucous membranes, you want to make sure you have your eyes, mouth, nose covered during this process. So I'm going to go ahead and take some of the sulfuric acid now and add it to the sugar. We should see a reaction begin fairly quickly. It's actually beginning to heat up just a little bit. It's going to get pretty hot. See, it's turning black, charring up. So it's dehydrating the water from the sugar and turning into pure carbon now. You should see the carbon begin to rise up out of the reaction. As you do the reaction, you notice the smell. It kind of smells a little bit like burnt syrup, precisely because you think about what syrup practically is. It's mostly sugar in there. So as you burn the sugar, it gives off this very unique smell to it. So with any chemical reaction, when you're talking about breaking apart bonds, forming new bonds, you're actually forming an entirely new substance. So in this case, we took sugar and we turned it into carbon. You see the tower of carbon here, as well as what you saw steam rising off, which was water vapor coming off, as well as some sulfur dioxide gas, and maybe even a little bit of carbon dioxide as well. So we took something that was composed of just one single molecule, and basically, by introducing an acid, turned it into several different elements. We got elemental carbon here, we had carbon dioxide, water vapor escaping the atmosphere, as well as some sulfur dioxide gas. Any remaining sulfuric acid has been pretty much neutralized by the addition of the base with baking soda. Baking soda is a fairly weak base, but just bringing that pH up even a little bit is going to help make sure that this is not as caustic as it was before. So we have 6 main types of chemical reactions. There's first a synthesis reaction, which is just joining 2 elements together to make a new compound, such as sodium coming in contact with chlorine to become sodium chloride. Sodium chloride is just table salt, put on your food, it's great. We also have single replacement and double replacement reactions, as well as acid-base reactions and combustion reactions. So here we have pretty much like a double replacement reaction occurring. The sulfuric acid, the hydrogen from the sulfuric acid, the hydrogen ions, basically were attracted right to the water, the hydrogen and oxygen bonds of the sugar. And when they got attracted to it, they broke apart carbon's bond with those particular elements. And what we're left with is the elemental carbon, and then water vapor, sulfur dioxide, and some carbon dioxide. So hopefully this has been a somewhat educational video. If not, I hope you at least found it interesting. If you would ever like to see anything more like this done again, please just feel free to let me know, and we'll try some other reactions as well. Thanks for watching.